Hi everyone, in this video we're going to be covering a section from grade 11 lesson 4, which is the section on electromagnetic waves and their users. So basically we've learned all about what electromagnetic waves are. So first of all, let's remind ourselves what electromagnetic waves are. They are the types of waves that do not require a medium to travel through. So they can even travel through a vacuum. And in addition to that, we've also learned of some other properties of electromagnetic waves. We've learned that electromagnetic waves are made up of an electric field and a magnetic field that are oscillating perpendicular to each other and perpendicular to the direction of the wave. And we've also learned that these electromagnetic waves are not affected by external electric or magnetic fields. And also the fact that these electromagnetic waves, they travel at an extremely high speed in a vacuum, a speed of 3 into 10 to the power 8 meters per second. So in this video, we are going to be focusing on the different types of electromagnetic waves and their users. But first of all, let's first take a look at what electromagnetic waves are. Now, in this diagram over here, you can see the sun, which is releasing some electromagnetic radiation. The sun actually releases 3 different types of electromagnetic rays, and these rays are able to travel through the vacuum, which is present between the sun and the earth. So this space is all a vacuum, and then these rays enter the Earth's atmosphere. So the fact that these waves are able to even travel through a vacuum proves that these waves do not require a medium to travel through, and that's what we define as electromagnetic waves. So electromagnetic waves are those waves that can even travel through a vacuum, and like I said, they are defined as waves that do not need a medium to propagate through. So this is how we define electromagnetic waves. And there are 7 types of electromagnetic waves. So what are the types of electromagnetic waves? They are radio waves, microwaves, infrared radiation, visible light, ultraviolet rays, X-rays, and gamma rays. Now, it's extremely important for you all to remember these 7 electromagnetic waves in this exact same sequence, because when you arrange these electromagnetic waves in this correct sequence that I've mentioned, this is what makes up the electromagnetic spectrum. So it's extremely important to remember these in this very same order. So how would you remember this order? Here's just a little tip for you all to remember if you all are struggling to memorize this order. Just remember this phrase: Rachel's mother is visiting Uncle Xavier's garden. So if you just keep this phrase in mind, remember that each of these letters, the first letter of each word, represents one electromagnetic wave. So R stands for radio waves, M for microwaves, I for infrared radiation, V for visible light, U for ultraviolet, X-rays, and gamma rays. So if you're struggling to remember this order, just try to memorize this little mnemonic I've given over here. So somehow it's very important that you remember this order so that you are able to build up this electromagnetic spectrum with this correct sequence of electromagnetic waves. So this is the electromagnetic spectrum. It starts off with radio waves and then microwaves, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays. And why is it important to memorize this spectrum? It's because when you go from one end to the other end of the electromagnetic spectrum, there are certain patterns shown in these waves. For example, if you start off with this end of the electromagnetic spectrum, you can see how the radio waves have an extremely high wavelength. They have the highest wavelength. And if you go all the way to the other side, the gamma rays, you can see how these waves have a very, very low wavelength. So radio waves have the largest wavelength, gamma rays have the shortest wavelength, And this change in wavelength happens very gradually from left to right. So this gradual change in wavelength is one pattern shown across the electromagnetic spectrum. But there are also two other patterns that you need to keep in mind. Now, we know the relationship between wavelength and frequency, right? We've learned that when wavelength is high, frequency is low. And when wavelength is low, the frequency is high. So basically, what I'm trying to say is that wavelength and frequency have an inverse relationship. So the fact that radio waves have the largest wavelength means that they would have the lowest frequency, and the fact that gamma rays have the shortest wavelength would mean that they have the highest frequency. So this is the second pattern that is seen across the electromagnetic spectrum. On one end, the radio waves have the lowest frequency, and then you'd see the frequency gradually increasing, and the other end, the gamma rays, have the highest frequency. Now, when talking about waves, we also talk about the energy of waves. And frequency and energy are two things that go hand in hand. So since radio waves have the lowest frequency, they also happen to have the least energy. And since the gamma rays have the highest frequency, they also happen to have the most energy. So from the radio waves to the gamma rays, you'd also see the energy increasing gradually across the electromagnetic spectrum. So these are the three important patterns that you'd have to learn: the pattern of wavelength, the pattern of frequency, and the pattern of energy. So basically, to summarize it, from radio wave to gamma rays, we see that the wavelength decreases gradually and the frequency gradually increases, and along with frequency, energy too increases from radio waves to gamma rays. So this is the reason why you need to memorize this correct sequence of electromagnetic waves in the spectrum. All right, so now what we're going to be doing is we're going to be looking at each of these electromagnetic waves in details, and we're going to focus on the users of these different types of electromagnetic waves. So we're starting off with our very first electromagnetic wave, which is the radio waves. Now, what do you already know about radio waves? What you know is that radio waves are the type of electromagnetic waves that have the highest wavelength. And because they have the highest wavelength, they also have the lowest frequency and lowest energy. That's what you already know about radio waves, because of the fact that the radio waves is the first one in the electromagnetic spectrum. Now, what are the users of radio waves? We use radio waves in long distance communications. So usually what we would do is that we have a radio transmitter which sends information in the form of these radio waves. And then you'd usually have a radio receiver. So we usually use antennas in transmitting radio waves. So you then have a radio receiver which receives these radio waves and then translates this information into useful information, which is then displayed through the radio or the television. So that is the main use of radio waves. Radio waves are mainly used in long distance communication to transmit information in the form of these radio waves. So that is simply what you needed to know about radio waves. The main use of it is in long distance communication. So now that we've covered radio waves, we are moving on to the second type of electromagnetic waves in the spectrum, which is the microwaves. Now, microwaves, the fact that they are the second type of wave in the spectrum means that they have a lower wavelength compared to the radio waves. And because they have a lower wavelength, they have a higher frequency and higher energy compared to the radio waves. Now, when thinking of the users of microwaves, the first thing that would probably pop up in your mind is the fact that microwaves are used in microwave ovens. Now, we all know how microwave ovens work. We usually use microwave ovens when we have like a food item which is cold and we want to heat it up. So we just put it in the microwave oven and put it for a couple of seconds or minutes. And then when you take it out, the food item is hot, right? So what exactly happens inside the microwave oven is that the microwave oven releases microwaves, and these microwaves, when they get into the food item, these microwaves release heat energy, which heats up the food. So that is one application of microwaves in the microwave ovens. But another use of microwaves is that microwaves too are used in long distance communication. So microwaves are made use of in mobile phones and in radar systems. So microwaves have many useful applications. So we have made use of these microwaves in the microwave ovens and in mobile phones and radar systems. But microwaves could also have adverse effects on our bodies. So overexposure to these microwaves could cause certain adverse effects on our bodies. And this is why certain people say that excessive use of mobile telephones can harm the brain, because mobile phones make use of microwaves for transmitting information. And also, this is why some people also advise that it's better not to stay too close to microwave ovens when they are in operation. So this is basically what you need to know about the microwaves. Just to sum it up, we've learned that microwaves are made use of in microwave ovens and also in mobile phones and also in radar systems. But it's also useful to keep in mind that these microwaves could have certain adverse effects to our bodies. So it's always better that when we are using a microwave oven, it's better not to stay too close to it, and also to limit our usage of mobile telephones as much as possible. All right, so now that we've covered radio waves and microwaves, we are coming to the third type of electromagnetic wave in the spectrum, which is infrared radiation. Now, what are infrared waves? They're basically a type of radiation that is emitted by heated bodies. For example, if you consider the sun is a very hot object. So the sun, which is a very hot object, which is a heated body, emits infrared radiation. And infrared radiation is also referred to as heat rays. Now, the fact that this infrared radiation is released by heated bodies means that these rays carry a lot of heat with it. So we call them heat rays. And infrared radiation is also emitted by our own bodies as well. You see, our bodies have quite a high internal temperature, right? Usually the internal temperature of a human body is roughly about 37 Celsius. So we can consider ourselves as a heated body as well. And our body too releases infrared radiation, which we commonly refer to as our body heat, right? So this is what you need to know about infrared radiation. It's usually released by heated bodies, and these radiation usually carry heat with them. So we call them heat rays. Right. So what are the different applications of infrared radiation? One use of infrared radiation is to take heat photographs. So heat photographs, which look like this, these are used to detect certain conditions and diseases in certain people. And another use of infrared radiation is that low energy infrared radiation is made use of in remote signaling. So what happens is remotes usually release low energy infrared radiation, and this IR radiation could be detected by a detector on another appliance, and this could transmit information accordingly. So it's used to send signals from remotes, and infrared radiation is also used in physiotherapy treatment. All right, so this is about infrared radiation. So we've covered radio waves, microwaves, and infrared, and we are coming to the fourth type of electromagnetic waves, which is visible light. Now, visible light is a unique type of electromagnetic waves because visible light is the range of the electromagnetic spectrum to which our eyes are sensitive to. So our eyes, the human eye, is only sensitive to visible light. We are only able to see visible light from the whole electromagnetic spectrum. So we're not able to see radio waves, nor microwaves, nor infrared radiation, or any other type of electromagnetic waves. The only waves that are visible to us are the visible light. And visible light is made up of 7 colors, and the waves corresponding to each color is different. Now, we all know that visible light is made up of 7 colors, and these are the same 7 colors that we talk about in a rainbow, right? So what are these 7 colors? They are violet, indigo, blue, green, yellow, orange, and red, right? Now, each of these 7 colors have different waves corresponding to each color. So what do you notice? The red light has a higher wavelength, and orange light has a lesser wavelength. And when you go all the way down to blue, indigo, and violet, these waves have a much lower wavelength. So each of these 7 colors have different wavelengths, different frequencies, and different energies for themselves, right? So it's extremely important to remember this order of 7 colors as well. And keep in mind that violet is the type of visible light that is closest to the ultraviolet rays, and red is the type of visible light which is closest to the infrared rays. So this is how you remember the order of the 7 colors. Red comes closest to infrared, violet comes closest to ultraviolet, and you'd probably be able to fill in the gaps between these 2 colors. Right. So what are the users of visible light? Visible light is extremely important to us humans because it's because of visible light that we are able to see everything around us. Every object in our environment is visible to us because of these visible light waves that allow us to see everything in our environment. So that's the use of visible light. And once again, it's extremely important to know how to arrange the 7 colors within the electromagnetic spectrum. So like I mentioned, keep in mind that red is closest to infrared and violet is closest to ultraviolet. And you should be able to fill in the five types of colors that come in between these 2. So it goes as red, orange, yellow, green, blue, indigo, and violet. All right, so that was what you needed to know about ultraviolet. What you needed to know about the visible light. And we are now moving on to the 5th type of electromagnetic wave, which are the ultraviolet waves. Now, ultraviolet waves are invisible to the human eye. And that's pretty obvious because I mentioned earlier that visible light is the only type of electromagnetic wave that our eyes can see. So obviously that would mean that ultraviolet is invisible to the human eye. However, there are some animals, some insects, such as bees, that can see UV light. And UV light comes with sunlight. So when sunlight comes into the Earth's atmosphere, sunlight brings ultraviolet rays with it. And these ultraviolet rays that come with the sunlight is important to us because these rays produce vitamin D in the human body. When these UV rays fall on our skin, it makes our skin produce vitamin D, which is a vitamin that we need, right? However, even though ultraviolet rays are useful to the human body, overexposure to ultraviolet rays can cause cataracts in the eyes and also skin cancers in certain people. So even though we make use of ultraviolet rays in different scenarios, in different instances, it's also important to keep in mind that these ultraviolet rays could have certain harm to the human body as well. So notice how ultraviolet rays, which are more towards the right of the electromagnetic spectrum, these rays have a much lower wavelength, and a lower wavelength means a higher frequency and a higher energy. So ultraviolet are high energy waves, and that is why they could have certain adverse effects to the human body. Right. So ultraviolet rays are also produced in electric discharge and from mercury vapor lamps. So keep in mind that sunlight brings three types of electromagnetic waves to the earth. It brings ultraviolet rays, and it brings visible light, as well as infrared radiation. Okay, so now we are moving on to the users of ultraviolet rays. Where and when do we make use of ultraviolet rays? Like I mentioned in the previous slide, one very important use of ultraviolet rays is that it helps the skin to produce vitamin D. So let's say that this is our skin. When ultraviolet rays fall on our skin, it promotes the production of vitamin D by our skin. So a little bit of exposure to ultraviolet rays is definitely important for our body to be able to produce vitamin D, right? And some other users include in hospitals to kill germs. Now, like I mentioned, ultraviolet rays are high energy waves. So this is made use of in hospitals because when they want to sterilize certain stuff, so for example, let's imagine these masks need to be sterilized. And let's say that there are some bacteria and infectious particles on these masks. When these objects are exposed to UV, ultraviolet rays have a high energy and they are able to destroy these infectious particles. So that is that is a use of ultraviolet rays in hospitals. Then ultraviolet rays are also used in banks to check for hidden symbols in currency notes. Now we've all seen some hidden symbols in currency notes. These prove the authenticity of certain currency notes. And sometimes these hidden symbols are very difficult to detect using visible light. So an easy way to detect these hidden symbols in currency is by using ultraviolet light. And this is why banks make use of ultraviolet rays to check for hidden symbols in currency notes. Then another application of ultraviolet is that it is also used in washing powders. Certain washing powders have the ability to release UV rays, which would give a bright shine to the clothes being washed. So this is what you need to know about ultraviolet rays. Make sure that you remember, make sure that you study a few users of these UV rays. So now that we've learned about UV or ultraviolet, so we've covered radio waves, microwaves, infrared radiation, visible light, and ultraviolet. So that brings us to the sixth type of electromagnetic waves, which are the X-rays. Now, X-rays, as you can see, they are almost to the end of the electromagnetic spectrum. So you can see how X-rays have a very short wavelength. And a short wavelength would mean that they have a high frequency and a high energy. Now, X-rays are something we have all heard of before, right? Most of us might have taken an X-ray for certain reasons at some point in our life, right? So that is the main use of X-rays. X-rays are mostly used to take photographs of internal organs. So let's say that someone has had a fall and it is suspected that the person has a fracture or a broken bone. Then it would be recommended to take an X-ray photograph of the internal organs. So how X-ray photographs work is that the person is made to stand in front of the X-ray machine, and the X-ray machine would release these X-rays, and X-rays are high energy waves, so they are able to penetrate through the human body. And if these X-rays pass through a soft tissue, these X-rays would come out of come out through the other side of the body and come on to this X-ray film, right? But if these X-rays happen to pass through a hard tissue, for example, a bony tissue, then these X-rays would be stopped by this hard tissue, and that would be shown as a white spot on this X-ray field. So basically, X-rays can travel through the soft tissues of our body, but they stop when they reach a hard bone. And this is how you get the X-ray photograph on this X-ray field. So this is one of the users of X-rays, but there's also an adverse effect that could be caused by overexposure to X-rays. Excessive exposure to X-rays can cause cancer. Now, we've learned that X-rays have high energy, so they are high energy waves. And if you are overexposed to these X-rays, they could penetrate through your body cells and cause some of your cells to become cancerous. This is only in the case where a certain person has been exposed to X-rays to a very high extent, right? Okay, so these are the main users of X-rays. The number one use is to take X-ray photographs. And another use of X-rays is also to examine baggages without actually opening the baggage. So you've probably seen these X-ray counters, right? Where you need to send your luggages or your handbags through before you enter a certain place. For example, this is common in airports, right? So what happens is that when these baggages are sent through this X-ray counter, the security standing on the other side could see the objects inside this baggage without having to open the luggage and examine what's inside. So X-rays can penetrate through this and detect the objects that are inside this particular bag. Right, so that's what you need to know about X-rays. And with that, we are coming to the last electromagnetic wave, which is the gamma rays. So gamma rays have the shortest wavelength and the highest frequency and highest energy. So gamma rays are the waves that are on the other end of the electromagnetic spectrum. And these waves have the shortest wavelength and the highest frequency and energy. So you need to remember that gamma rays are extremely high energy waves. Now, where do gamma rays get released? There are some radioactive elements that are able to release gamma rays. Some radioactive elements such as uranium, plutonium, these elements are able to release gamma rays. And remember that gamma rays, they are high energy waves that can come into our body. They can penetrate into our body and cause damage to our body cells, right? So not just through our bodies, gamma rays can even penetrate through thick sheets of steel as well as a concrete slab. So let's imagine that there is a gamma ray that is coming, all right? And let's say that you hide behind a concrete slab or a thick sheet of steel. This is going to be of no use because gamma rays are extremely high energy waves. They can even penetrate through a thick concrete slab and come out of the other side and penetrate through a person's body. So this is what you need to know about the gamma rays. They are extremely high energy waves that could penetrate through our body, and sometimes they cause damage to our body cells. However, the fact that these gamma rays can destroy our body cells is made use of in cancer treatment. Let's imagine that there's a person having a certain tumor with cancerous cells, and a doctor wants to destroy these cancer cells. So an easy way to destroy these cancer cells would be to pass gamma rays, to target gamma rays right onto these cancerous cells. And when these gamma rays fall onto these cancerous cells, they would destroy those cells. So this is one application of gamma rays in cancer treatment. And one other application is to sterilize surgical instruments. You see, before surgery, a surgeon would want to make sure that his instruments are free of any bacteria, fungi, or any other microorganism on it, right? Because these instruments are going to be used in surgery. So what would be done is these instruments would be exposed to gamma rays. We know that gamma rays can penetrate through cells. So these gamma rays, when they hit on these different microorganisms, they would cause all these microorganisms to die, and they would make all of these instruments sterilized. So that's what you need to know about gamma rays. And with that, we have come to the end of all the types of electromagnetic waves. So we've discussed we started off with radio waves, then moved on to microwaves, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays. So this brings us to the end of this video. I hope all of you got a good understanding on this topic. Thank you.